not using the altitude. Altitude, that thing that goes from a vertex to the opposite side of 90 degrees, we're not touching it. So we're not using the altitude. Are we going to end up using the L or the T?
L.
We use the L. Now it's going to look like a backwards L for us. We know we're going to use the L formula, okay? If we're just using the L formula, we're going to always have to start 90 degrees on the hypotenuse. All right, so we're going to start there. Get a full proportion up. We'll go, we know one piece to the left, we know two pieces to the right. We'll go to where there's more information. So I'll go 1, 2, 3, 4. Now the setup's pretty easy on this one. Start here, x plus 2, back over, x plus 2, and then all the way up. Now how big is all the way up? Don't say 5x. X plus 5. Thank you. Now, put your algebra hats on. You're going to need them. Cross multiply. What is x times x plus 5?
X squared plus 5.
X squared plus 5x. You have to distribute x times that, x times that. Now, x plus 2 times x plus 2. We get a FOIL. X squared plus 2x plus 2x. First, outside, inside, last, plus 4. Combining like terms, I end up at x squared plus 4x plus 4. Now we got to solve this thing for x. So we got to get everything, all of our like terms together, combine our x squared, combine our x's, combine our constants. Now, remember, how do I move this x squared from this side to that side? Subtract it. If I subtract an x squared from both sides, lucky for me, no more x squared. I'm left with 5x equals 4x plus 4. Now I just got a little two-step equation. Do one-step equation. What would you guys do next? Subtract 4x. I get x equals 4. That's not as bad as it was. 7 through 1. You want to see anyone in particular done other than number 6? 7. Okay, now think about number 7. Deal with one variable at a time. And the way they have this set up, we can solve for either one first. So which one do you want to solve for first? Solve for y first. Okay. So forget x is even over here. Now, we're going to solve for y. Are we going to use the altitude? Yeah, y is the altitude. And if we're ever using the altitude, we'll use what formula? The T. Now, you got to tilt your head to the side a little bit to see the T you're going to make. But whenever we use the T formula, we start not touching 90 degrees. We're on one of the corners, not touching 90 degrees. So I can start here. Or I can start here. Doesn't really matter. I'll start at the top. Make my T. 1, 2, 3, 4. Alright, so then when I fill it in, 6, y, 24. 6, y, 24. Again, it's got a proportion. How to solve proportions? Cross multiply y squared equals, I'm guessing that's 144. Yeah. How do you unsquare something? Square root it. And y equals 12. Now, forget everything we just did. And let's solve for x. Let's solve for x. Now, if we solve for x, completely forget about that. Are we going to use the altitude when we solve for x?
No.
Nope, so we will use the and start on the 90 degrees. Now, we know one thing to the right, we know two things to the left. So which way are we going to go first? Yeah. 6, x, what's that?
30.
30. Thank you very much. So 6x, x, 30. Add those together. Add those together. All right. So then I go through, cross multiply, I get x squared. And you know I don't like multiplying with numbers, get big numbers just to break them down again. So I get x squared equals 6 times 30. What gives me 30? 6 times 5. Now I'll take the square root of that all day long. The square root of x squared is x. We take the square root of something. Look, I got 2 of those. Which means we're 1 on the outside, the 5 trapped in. Not too bad. A little better today. See if you can do 3 of them on your own. Grab a scratch piece of paper. So, grab a piece of paper. If you want to sit by somebody, work with somebody, that's fine. I have no problem with that. It's technically 4 problems, but it's 3. I'll give you a hint on 3. A hint on number 3. You have to solve for x first. Use a big little half sheet. You can share with somebody, make a friend. You have to solve for x first on number 3. 3 problems, 5 minutes, doable? Yes, no? Maybe. Maybe? Can you do these 5 minutes? You want to work with somebody, you want to compare answers with somebody, feel absolutely free to do so. close? Very good. Tired of doing all the work in here. You get to start out.
I'll do the second.
Sounds great.
I'll do the
Got X on the third?
yeah.
Just do this whole third one like that. You can change colors if you want. Just
Okay.
tap whatever one you want. Yellow's hard to see.
Okay, I'll do some.
Squared equals 6 times 12, which is really 6 times 6 times 2, I agree. Why did you see choked out? Label it January 6th. It's good, it was very good. No. Not using the altitude, so we'll go for the L. 4 over X equals X over 12. That 12 is where you're going to make your mistakes. Remember, you add the whole bottom. Don't just leave an 8 there. Careful, you just divide it by 2. You got to take the square root. So you're going to think, oh, let's break it up 48. This is 48.
1, 4.
So, cut 48. Square root times 3. So we break down 16 times 3. Square root of 4. What is the square root of 4? There we go. 4 out of the 3 looks fantastic. Everly. Questions like number 3. I'm going to stop giving the hints. You eventually going to figure out what you got to solve for first on your own. 5 over 10 equals 10 over x. Very good. Easy little cross multiplying. 5x equals 100. X equals 20. Then you've got to plug in 20. You got to use that 20. Y. The L formula. Break it down so they get the big numbers. Got 2 5s. Square root of 4 is 2. Beautiful. Said you got to do my job more often. Alright, we'll do a couple of those beginning class next couple of days. Just get used to it. It's something weird. I understand that. But we're going to move on today to a very easy addition to the... Where am I going? I'm going... Yeah. Very easy addition to our repertoire, because you guys I guarantee have seen this. We're going to talk about the Pythagorean theorem and its converse. I remember converse is just doing the same thing backwards. Normally, everything we do forwards is going to work just as good backwards. The converse of the Pythagorean theorem is no different. What are we actually going to do today? Get these written down. I'll give you a little bit of time. We're going to use the Pythagorean theorem. Some of you guys can probably already say it because you guys have used it. It's going to look very familiar. I don't need those two problems just yet. We use the Pythagorean theorem, and we're using the converse. You can say use the Pythagorean theorem and its converse. Save some writing. I'm fine with that. Because the converse is all that different from what we're really doing. It's just more of a proof. Anybody, I know somebody in here can. What is the Pythagorean theorem? Remember that back page of your notebook that I said you put the most important things on, so you know right where it's at? Then we got the slope formula, the midpoint formula, the distance formula in there already. Ooh, have we already put the Pythagorean theorem in there?
Yeah.
First one we did, nice. We're going to use it a bunch. We're going to talk about it a bunch. Later on, we're going to be doing these super hard problems, and eventually you guys are going to realize I could have used the Pythagorean theorem 5 minutes ago, saved myself a ton of time. It's a time saver because it's so easy to deal with. Use the Pythagorean theorem in the converse. And we're going to yell when I switch. Alright, Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the legs. So through all this, we need to talk about a couple things. First thing, hypotenuse. Where is the hypotenuse always located? It's always C. It's always the longest side. It's always across from the 90. Has to be across from the 90. Has to be across from the 90. What are the legs? A and B, they're the, well, for lack of better terms, they're not the hypotenuse. They're the other parts of the triangle. So just don't get confused if we start talking about the legs and the hypotenuse. Just realize legs are touching the 90, hypotenuse across from the 90. And the big thing with the Pythagorean theorem that I want you to write down, C is the hypotenuse. Every time, no question asked. The hypotenuse has to be C. It doesn't matter what leg is A, it doesn't matter what leg's B. I mean, your longer leg doesn't have to be A, your shorter leg doesn't have to be B. You can switch your legs around back and forth all day long, but your hypotenuse has to be C. And it has to be the largest side. That's going to come into play when we talk about the converse. Your hypotenuse has to be the largest, biggest number. Good job. So we can talk about this, and you can use it to find a whole bunch of stuff. They're talking about latitude and longitude. It says Carson City, Nevada is located about 120 degrees longitude and 39 degrees latitude. And NASA Ames is located about 122. That's all a bunch of numbers trying to screw you up. Look at the pictures, which is very nice. Use the lines of longitude and lines of latitude. Help me out. What goes horizontal? Longitude horizontal? That's more of a question. Yeah? So the nearest tenth of a degree if you were to travel directly from city to city. Okay. Here's what it basically says. It's not going to show up. How far is it from here to here? By the lines of longitude. 2. How far is it from there to there? Is it? 1 2/3. Fraction. We'll start the whole time we do this. Start off with the fraction. Let's do it this way. Latitude. Latitude 37. Latitude 39. By this is 2. Our picture's off. Our latitudes are 2 off. Our longitudes are 2 off. So we got a 2 by 2. Now this is, we're going to assume a 90-degree angle. So we have a right triangle. Right triangles are cool using the Pythagorean theorem. Do I know the legs or the hypotenuse? I know both legs. So in my a squared plus b squared equals c squared life, do I know A, B, or C with these two 2's? I know A and B, so I'm going to plug them in. 2 squared plus 2 squared equals C squared. Now, that means C has to be the A squared. Which also means it has to be what in 2 and 2? It's got to be larger than 2 and 2, so let's talk about it. What's 2 squared? 4. What's 2 squared? What is it? Tough math we're starting with today. 4 plus 4. 8 equals C squared. Nah, think about it. You have to unsquare something. Square root it. So we get the square root of C squared is C. Square root of 8. What's the perfect square of 8? 4 times 2. What's the square root of 4? What's left inside? I'll tell you right now, this answer I love. This answer, 8. Don't run to your calculators and start giving me decimals. I'm going to count them wrong. I want reduced radicals. We can do it. We're going to brag about it and do it all the time. So let's do another one. Like this one. Look at that. It's going to make me sick to even watch. No, I don't like this. Notice the extreme difference from there to there. What's this mean? Equals. Approximately. Here's the problem with approximately. So it's approximately 2.8. That's great. When we start cubing stuff, approximations triple. You end up with these huge differences in answers. I don't like approximations. We start cubing square roots. Yes. Don't give me decimal answers. But watch how we do this with B. Find the third side. Okay, so the thing you have to ask yourself at the beginning of every one of these problems, do I know A, do I know B, do I know C? I know A and C. So right now I know that it would be 3 squared plus B squared equals C squared. Don't make this mistake. 6 squared minus 3 squared is 3 squared. Don't do it, it doesn't work. 3 squared? 9. B squared, B squared, 6 squared, 36. Look at the two-step algebra equation. Next step. Tell me. Subtract 9. 36 minus 9, not 25. 27. Alright, I have a b squared. I have to unsquare it. The opposite of squaring. Square root. Square root. Perfect square times 27. 9 times 3. Reduce it for me. 3 radical 3. Pretty simple. Feel confident and know we can do this? What 2 letters do I know? A and C. Could I know B and C? Yes. Does it matter if I know A and C or B and C? No, not at all. So I'm just going to go A squared plus what? 8 squared equals C squared. Alright, 8 squared? 64. 15 squared? 225. 60 or 2 225 minus 64. Grab calculator if you need one. Type your own word. 160. What goes into 161? Did I start with the 225? No. Square root of 161. Does anything go into 161? Does 2 go into it? You guys remember the rule? Like 2, they're even, it'll go into it. 3, the numbers in there will add up to a multiple of 3. So like 1 plus 6 plus 1, that's 8. That's not a multiple of 3. So 3 won't go into it. 4, I can't remember. 5, ends in 5 or 1. 6, 2, and 3 both go into it. 7, I can't remember. 8, 2, and 4, something weird. So it's done? That's all we can do? Ugh. Doesn't feel right. Oh, well, that's the answer. Yeah, we're right. Alright, here's the converse. Now, this is not mind-numbingly exciting. If the square of the length of the long side of the triangle is equal to the sum of the squares of the length of the other two sides, then the triangle is a right triangle. All that's saying is you know what side is A, you know what side is B, more importantly, you know what side has to be C. If the two smaller sides squared and added together equals the third side, then it's a right triangle. Basically, they're just going to ask you to use the Pythagorean theorem to see if it's a right triangle. But they might not always give you the length. You might have to do a little work to find it. Give me a coordinate plane word for length. Starts with a B. Distance. It's like it's never going to go away. It just keeps coming back over and over and over again. Guys, remember that? Alright, so I'll find the distance AB. Distance AB. X minus x squared. Now, since I started with negative 9 minus 1 squared, what do I have to start with for my y's? I've got to start with the same ordered pair, right? So negative 3 minus negative 1 squared. So 9 minus 1, negative 9 minus 1 is negative 10 squared plus 3 minus negative 1 is negative 2 squared. Negative 10 squared is 100. Negative 2 squared is 4. So I get the square root of 104. Now, well, right now, it would be beneficial for you to not reduce these. I'll show you why. Alright, so I need to get AC and I need to get BC. What do you want me to do? I'll do AC. You guys do BC. I'm just going to ask you for the answer. So do BC. The distance of BC. I got AC, right?
Yeah. What do you got? 45? 405? What is it before you reduce it? 52? 52? Square root of 52? Square root of 52? You don't want to reduce it. Mine says 213.
The calculator is going to reduce them automatically. That's fine.
Yeah.
But it's going to make more work for you if it is reduced. That's 2 root 13. I think that's right. That's 52, right? Are you guys getting square root of 52? square root of 52? Check a negative sign, not true. Square root of 52?
4 times 13 equals 250.
Okay. Now here's why. You gotta use the Pythagorean theorem. What's bigger? 104, 52, or 52? So which side has to be our hypotenuse? AB, AC, or BC? AB has to be our hypotenuse. Okay. So we can talk about the Pythagorean theorem. We've talked about this multiple times. Square root of 2 squared. Really equals the square root of 2 times the square root of 2, which really equals the square root of 4. You all agree? Which really equals 2. Square root of 3. Squared. Really equals the square root of 3 times the square root of 3, which really equals the square root of 9, which is really 3. Kind of see the pattern that if you square a square root, what do you get? Whatever's inside, right? So this is why I didn't want to break them down, because right now as a habit, I have the square root of 52 squared plus square root of 52 squared equals square root of 104 squared. Don't overthink it. What's the square root of 52 squared? 52. What's the square root of 52 times the square root of 52? 52 is the square root of 104 times the square root of 104 is 104. So when I look at this, what's 52 plus 52? 104. Does 104 in fact equal 104? Yes, so by using the converse of the Pythagorean theorem, we learned that this is a right triangle. Now, which angle would be your right angle? Yeah, angle C would be your right angle because it has to be across from the hypotenuse.